Alright, hey there fellow coder, welcome to this next video in our FreshVotes series where I show you how you can build an entire web application from scratch using Java and leveraging Spring Boot technologies as well as many other technologies as well. So inside of this code here, we had created sort of in the last video we enabled CSRF protection. So now basically what we need to do is change our default implementation of our users here, because right now we're just sort of hard coding the users into an in-memory database, and we don't want to do that. That's not production ready. You don't have an in-memory database in production and then hard code users in there. You could, but that would be really, really weird, because that would also be very hard to allow for new users to sign up. But anyway, that's neither here nor there. The requirement we have here is we want to actually leverage a real database that has actual users inside of it. So this is going to be a bit of an epic journey. And by that, I mean it probably will span a couple videos. So let's just dive right in. So basically, instead of leveraging an in-memory authentication here with a password, let me just comment all of this out. People always ask me what the shortcut keys are. In Eclipse or Spring Tool Suite, you can hit Control-Shift and then C, and if you hit Control-Shift-C, it'll comment out whatever it is that's selected, right? So if you had selected just this row, you can uncomment and comment out this row. Anyway, Control-Shift-C is the shortcut key combination. So in here, we want to do auth dot, and if you want to, essentially the concept that we're going with is we have a database, a MySQL database, or it could be any SQL database, maybe even a NoSQL database. Although I wouldn't recommend a NoSQL database unless you know that you're going to have millions or billions of users. It's a bit overkill if you use a NoSQL database for a small app like this, in my opinion. So let's leverage a SQL database, and we're going to be doing that, and we're going to be storing our users inside of the SQL database. So that means that we essentially need to use a custom user detail service. So if you look at user detail service here, you can specify a user detail service to leverage. Okay, we haven't created this yet. This doesn't exist yet. This is what we are going to be creating. So we'll do that. And we also want to make sure that we leverage a password encoder, just like we did before. So auth dot, I guess I need to specify a user detail service first. So let me create a field. Okay, I'm going to click on create a field, which creates it up here. Okay, and then can I say dot password encoder? There we go. Password encoder will be, I think it's just password encoder or get password. Okay, get password encoder is what we're using before. We no longer have to say with user password encode or roles. We don't have to do any of that anymore because all that's going to be encapsulated, if you will. It'll be housed inside of our user details service. Okay, so that's more or less all we need to do there, but then you might be thinking, oh, okay, we're done. No, we're not done. We need to actually create a user details service implementation, because if you look at the user details service, if I control click on it, you'll see that this is a Spring security thing, and it's literally just an interface with one method. Okay, so this, because it's an interface, there's no implementation yet. We need to create the implementation. And the implementation we need to create, the code we need to create, needs to leverage this method. In other words, we need to load a user by their username, passing in a username, and returning something called a user details object, which is a Spring security object. Okay, so let me dive into all of that glorious stuff. So let's first create a user details service. So it's a service, which means essentially your database, your app is mostly split into three parts for the most part. There's more parts, but in general, it's three parts. You have your controllers, which is sort of the front end work from the back end side. So it's the on the Java end of things, which is the back end. Your first responders, if you will, on the Java end, on the back end, are controllers. Your controllers are what listen for requests coming from the web. So if someone types in freshvotes.com, it will be listening for that, and it'll say, okay, someone has requested freshvotes.com, now what? Okay, that's what the controller does. It decides what to do when it receives a request. That's your controller. Then typically controllers, and this is a good design pattern, controllers sort of, once they have received a request, they send that off to a service. So a service sits in the middle here, and it says, okay, the service is typically what does the work. What does the business logic, if you will. And then as the service is doing its thing, typically a service needs to talk to a database, right? The service will fetch data from a database, do something with that data, and then pass that back to the controller, which will then send it to the view, which is the HTML page that the end user, the client, is looking at. They're on the page and they want to see whatever it is that they requested. So for example, yeah, that's the layout. Controllers, services, and then with a database, it's typically some sort of database access object or repository. Those are synonymous. DAO/repository, those are synonymous. So that's essentially the breakup here. 3 different sections: controller, service, repositories. So this is the service. We were working with a controller, which was right here, the dashboard controller. That sort of gets, requests and so on and so forth, and then forwards it onto something. So when someone tries to access the dashboard, it actually says, no, you need to log in first, and this is where we're at. We're logging in, so we need to do something with that. So inside of our configuration, we are, importing, or we should be auto wiring in this user detail service. So really, I should be auto wiring this in. Auto wired, which takes it from, when you auto wire something, it takes the object that should be managed by Spring, and it uses it. So I'll talk about how you get Spring to manage this particular object for us. So let's create it. So all that is to say, the web package that I've created here are the controllers. Those are your first responders. We don't have a package yet for services, and we don't have a package yet for repositories. So we need to create a package. So new package com.freshvotes.service. Okay, piece of cake. So inside of the service package that we just created, let's create a class, and we'll call this the user details service. Now you might want to call it the user details service, but you can't because that's already been taken. It's an interface. So typically when you have an object in Java that is implementing an interface, you call it an impl, IMPL. Okay, it's a convention that you should abide by, and we can say, if we want to, you can say add an interface that it implements, user details service. User details service. How come I can't? There we go. So it'll implement that interface. All that does is it adds a little bit of code, like code generation or whatever. So if I click finish, all that did is it just puts this in, implements user detail service. So if I hadn't added the interface there, it would have just created this. Oh, I guess it created this too. I should say it creates the stub as well. So if I just said create it without anything, it would have done this, public class user detail service impl, and I would have to say implements, user details service. And then when I do that, it says, hey, you need to override the load user by username that we saw before. So we need to add implemented methods, and then we'd be here, right? So it's, a few extra steps that you need to go through if you don't do it. If you don't do it inside of that screen when I said new class and I added the interface, if we hadn't done that, then anyway, you'd have to do all this sort of manually. But that's neither here nor there. So we have our user detail service impl, which is the implementation of the user detail service, which comes from, like I said, Spring. That was this guy. That's the interface that requires you to override this one method. Well, here's that method right here. User details object is what it returns. It's called load user by username, and it's passing in a string. So now we need to have this do something, right? How the heck do we have this do something? Or rather, what should it do? Well, the whole point of this is it should access our database, look up the database to see if there is a user with the username that's being passed in. And if there is, then we need to match the password to make sure that the password typed in when the person logged in matches what's in the database, right? You need to make sure your passwords match. Otherwise, what's the point? So that's essentially what this needs to do. look up a user, see if it exists. If it exists, then it needs to check the passwords to make sure they match. That's it. So how do we do that? Well, this is where we need to make use of the third general part of an application, which is repositories. Controllers, services, repositories. Remember I said services typically need to interact with repositories? Well, this is the situation we're in. Our service needs to interact with a repository that doesn't yet exist. So let's create our repository. First, let's create a package called repositories, I guess. And then inside of this package, we will include an object. And this object is actually going to be an interface. So I'm going to be leveraging something called Spring Data. I know I'm throwing a lot at you right now, but this is very common stuff. So you'll see me do this over and over again. And hopefully as you see me do it over and over, you will become more and more comfortable with it. So we need to create an interface. And the reason why I'm creating an interface and not a concrete class is because this is what is required to leverage something called Spring Data JPA. Spring Data JPA is a product given to us by Spring. It's code that allows us, it makes our lives easier as Java programmers. Specifically, it makes the CRUD operations very simple when interacting with a database. What is CRUD? CRUD is what you do all day, every day as a programmer. Creating data, reading data, updating data, and deleting data. CRUD, CRUD, create, read, update, delete. CRUD. Okay, those are the four things we do all the time. It is boilerplate code that you write over and over and over again. And finally, the people at Spring said, enough is enough. We're going to abstract out all that boilerplate code for you, and we're going to implement it for you because it's always the same. And we're going to call this Spring Data. So that's what we're doing. In order to leverage Spring Data and make our lives easy as programmers, we need to create an interface, call it whatever you like, almost whatever you like. Typically, it should end with the word repository. Repository. That's just a convention that's not required. Sometimes I get lazy and call them repos. You can do whatever you like, but that's the convention. It would be nice if you did that, if you ended it with repository. And what is this repository? What are we fetching here? Okay, what are we getting from the database? Well, here we're looking up users. So this is going to be a user repository. Okay, so we'll do that. Public interface user repository. And this is going to extend, and this is where Spring Data comes in. Spring Data offers a class to us called JPA repository. Okay, so extends JPA repository. And then it wants two templated generics here. It wants to know two things. The first thing it wants to know is what is the actual data type that is being essentially interacted with here. So really, I just look at what I just wrote here. It's the user, right? This is the user object, the user domain or entity is what we had created earlier in another video. And that's in our domain package. So that's what it's doing here. It's reading our users from the user table in our database. And the second option here is what is the data type that our object is using. I should say data type. What is the data type of the ID that our object is using? So right here, our ID is a long data type. So it just needs to know what the data type is. The reason why it needs to know, I'm actually not entirely certain. I've never looked into it. I just put it in and go about my business. There must be somewhere in the JPA repository, it must need to leverage this. If I click on it and open it up, it must need to leverage. Okay, there we go. So it needs to know what the data type is because it needs to possibly iterate through the IDs in one of its methods and so on and so forth. So that's the reason why they're right there. And get one needs to know the ID as well. So it's just these are just generics. This is Java generics at play. And it allowed the Spring people to make this JPA repository very generic and work in pretty much all instances. So, but that's it. We've now created a repository, and this will, with the little bit of code that we see here, if we get rid of our imports, this is really, 3 lines of code or whatever. With this code, we now have created an object that will do all the CRUD operations, create, read, update, delete. It allows us to do all of that in our database. So that's really, really cool. So we just created a user repository. And now let's go back to our service that we were interacting with. Because remember I said in our service, it needs to do a few things. It needs to read a user, see if the user exists in the database, and then match the passwords and everything. So we can actually bring in, auto wire in the object that we just created, the user repository object, user, I call it user repo as the variable name, and I'll do Control-Shift-O to auto import this stuff. And now we can leverage this user repository. Watch this, user repo dot. Look at all the beautiful stuff that we have that we can do. We can count, we can delete all, we can do exists, we can find all, we can find one, we can save, so we can do all the CRUD operations and a bit more with our user table, essentially. Very, very cool stuff. So one thing, although because we're given a username, we actually need to do one more thing here. So the CRUD operation, so specifically the reading operation is what we want to do right now. In terms of reading, what we can do, reading is find. We can say find all by ID, and find by ID, find one. So with all of this stuff that we have here, we are not exactly able to do what we need to do in terms of querying by username. I mean, we might be able to leverage this one. I've never actually looked into this. Returns a single entity matching a given example. I don't know. We might be able to leverage this one, but instead, this is what I usually do. I type in find by, and then whatever it is that I need to find stuff by. So find by username, and this doesn't exist yet. So we say find by username. We're passing in a username. This doesn't exist yet, but I'm going to hover over it and say create the method, and it'll create it for me inside of the user repository, find by username. Now it's created with a void return type. We want it to actually return us an actual user, right? We want it to bring back a user from the database and give us a user. So I will save, and this, believe it or not, will actually do the correct, will actually implement and run the correct select statement on the database side. And the reason why is I'm using their convention of find by. If you say find by, and then type in proper camel casing, a property that exists on the object that the entity that you're dealing with, it just knows what to do. So the reason this works is because in the user object, we have a username field or property. Because we have a username here, this find by username works. If we had typed in something like, find by gender or something like that and said save, it gives you an error. It says, well, invalid it's called a derived query. No property gender found for the type user. So we're looking for the property called gender, but it doesn't exist. So there's no gender inside of our user class. So this doesn't work. But since I typed in username, it matches it to the property inside of the user, and voila, it works. So that's really, really powerful stuff. So now we can say find by username, and it actually returns a user object to us, right? At least it should if all goes well. So let me import the user. Okay, now this video is getting a little bit long, so we're probably gonna have to, go into our next video where we dive into how to handle this situation here. Well, first let me say this. I'll do one more thing. If the user is null, which means it didn't find anything, then you can throw this username not found exception. Throw new username not found exception, and then you can put in quotes, username. Now you could say username not found as the message that you give back, but then that's kind of opening up the floor to hackers to find out which usernames exist and don't exist very simply. So instead of saying username not found, I'm actually going to be a little bit more vague here. I'm going to say username and password didn't match, right? So we'll say invalid username and password, right? That's gonna, it makes things a bit more difficult on our users because maybe our users think they're typing in the correct username and they're not. But it's for me, it's I feel I sleep better at night knowing that I'm not allowing hackers the opportunity to know which usernames exist and which usernames don't exist based on the messages that I give back. So anyway, that for now is what we will implement in our code base. Now, the next problem in the next video that we need to tackle is this. Because if I say return user, that's kind of what I would want to do, right? I want to return the user that I found, but the problem is the user is of type user, and it wants a type user details back. So what's going on there? Why there's this mismatch? How do I turn a user into a user details object to satisfy the requirement that it requires you to pass back a user details object? Also, I want to talk about password matching because right now all we're doing is we're looking up a user by username, but we're not matching any passwords. So we'll tackle that in the next video. Looking forward to seeing you there. Happy learning as always. Take care of yourself, and bye for now.